Hello everyone, this is lecture number 15 of transportation engineering, and in last 3 or 4 lectures we are studying traffic engineering. From last lectures we have started the traffic study portion, the portion in which we will try to find out the various parameters and will try to see how the parameters are being used or what values of parameter are being used to design various features on the road. So in last class, we studied about uh, traffic flow studies, and we saw traffic capacity studies. In traffic flow, the traffic flow value, that is 30th hourly volume, is very important because that volume is used to design the traffic facilities on the road. So you should remember 30th hourly volume is the volume which is exceeded 29 times or in 29 hours of a year. So we design the road facility for that volume, and that is around 8 to 10% of your AADT value. Then we saw traffic capacity studies. We know the maximum flow value or maximum volume value is known as capacity. So we used space headway and time headway to calculate the traffic capacity. The formulas which we derived by interchanging the units or by managing the units, you should remember those formulas. The formulas of space headway and time headway, which we use in order to find out the capacity. The capacity of a road is a quantitative measure of traffic condition. The capacity tells you about the quality of flow or quality of the road condition in terms of quantity of vehicle. There is one more parameter which we can use in order to find out the quality of the road or quality of the traffic flow. That is level of service. So we will start with level of service today. Level of service, it is a qualitative measurement. What kind of road it is in terms of quality. There are no numbers. So the qualitative measurement of flow describing the operational condition within a traffic stream and their perception by drivers and passengers. Whenever you are traveling on a road in a traffic stream, what you think about the road, what your perception is about the traffic condition. This is what level of service gives you. Level of service are defined in 6 levels, or they are classified in 6 levels from level A to level F. Level of service classified from level A to level F, total 6 level of service. Level A being the best with a speed of stream equivalent to free flow speed, and level of service F being the worst with a forced condition when the condition is of maximum flow, maximum, or the flow is equivalent to the capacity, because beyond the capacity you cannot have a flow. So this is the worst condition of flow. So why these level of services are important? Because for a traffic condition there should be better level of service. For any road, whenever we design facilities like intersection, like signalized portions, like overbridges, we need to keep this thing in mind, that level of service which we provide for that road or the route is of a better value. So level of service A, that is the best level of service, this gives you a speed equivalent to 90% of your free flow speed. The speed is equivalent to 90% of your free flow speed. Means if this is a section which we are taking from this route there will be only your vehicle will a specific distance, or there will be vehicles but with a very large gap between them or large headway between them. So level of service A is the best level of service, and it is seen on the expressways. Level of service B is slightly less in comparison of service with level of A. In terms of service, if we compare with level of service A, here the speed is around 70% of free flow speed. So there may be another vehicle in this vicinity, but the interaction between these vehicles will not be there. With increase in level of service from B to C, C to D, the condition of the traffic here increases. If the traffic increases, the number of vehicle increases, the interaction will increase, and this will hinder our speed also. I will not be able to maneuver through this traffic with my will. There will be slow moving vehicles in front of me. There will be congestion condition in front of me. So coming from level A to B, B to C, C to D, D to E, E to F, the condition of road in terms of volume, this deteriorates. And finally, the level F tells you about the speed which is forced due to other vehicle or the traffic condition. There may be breakdown, there may be congestion because of jam. So this is the highest flow value, or it is the value of capacity, or it denotes the value of flow reaching the maximum value for this level of service. So whenever we design a road, we try to give a better level of service, and with time this level of service reduces. Let's see this with the diagram between speed and flow. So the relationship between speed and flow is such, we have already seen something like this. Level of service A is somewhat here, where this is your free flow speed, your speed free flow, 90% of free flow speed, and your flow value is not that much, or the traffic volume is not that much. You can write here volume. As this is level of service A, as the flow increases, your speed will decrease. This is level of service B. Then again flow increases, level of service C, level of service D, level of service E, and finally the value of maximum flow will be attained. If the value of maximum flow or maximum volume is attained, this denotes the level of service as level of service F, and here the speed is 50% of the average value, or your free flow speed, or this speed will be maintained because of other vehicles. Whatever the speed we can maintain in this type of condition will be maintained because of other vehicles, because there is a lot of interaction between various vehicles which will hinder our, or which will or our traffic maneuvering will depend on other vehicles, completely depend on other vehicles. It will not be upon our choice. So level of service F is worst level of service, level of service A is the best level of service. There may be questions depending on the condition of the road, which will say you identify which level of service is this, or whenever you are given the capacity of the road, you can say this is a quantitative measurement of road quality. or traffic flow quality. And if we say level of service, it is a qualitative measurement of what kind of conditions are present on the road. So next we will talk about summarizing the type of vehicle which are moving on the road. When we see a road, there may be a two-wheeler, there may be a non-motorized vehicle, there may be a three-wheeler, there may be a bullock cart, there may be a horse cart, there may be a tractor, there may be a trailer, truck with a trailer, there may be a bus. So how these different category of vehicles can be summarized in one? Whenever we are looking at a road, we will say the volume of traffic will be this much, around 500 vehicle per hour, or density of the traffic will be this much, around 400 vehicle per kilometer. So these vehicle, if we are counting different vehicle, it will be very difficult to quote the value of a volume or quote the value of density. So in order to make things easier, we will convert all the vehicles into a standard vehicle. We will convert all the vehicles like trailer, like buses, like bullock carts, like rickshaws, like three-wheelers, like two-wheelers into a single unit, and that unit is known as passenger car unit, PSU, PCU, sorry, PCU. So passenger car unit is considered as standard vehicle unit, and other vehicles are converted into PCU. For mixed traffic condition, where there are number of different types of vehicle, we will quote the value of traffic volume or traffic capacity in terms of PCU per hour or PCU per lane per hour. Traffic density can be quoted as PCU kilometers per kilometers. This PCU value depends on the speed of the vehicle in the particular pertaining condition, and the length of vehicle, length and width or the dimension of the vehicle. The speed of the vehicle is for pertaining condition. What is pertaining condition? The conditions which are actually present on the road, depending on those conditions. When there is jam, all the vehicles will be moving with a very low speed. So we cannot compare the speed of a bullock cart or a car moving in a jam condition, because they both have different conditions. So that's why we say the speed of the vehicle in pertaining condition. So whenever there is a cart, it will always move slower than other motorized vehicles. Whenever there is a human pulled rickshaw, it will be having lower speed as compared to other motorized vehicles or motorized three-wheeler. So the speed in the particular condition will also affect the PCU value. Another one is length and width, that is dimension. This ought to hamper or affect the value of PCU, as if there is a bus, the bus will uh, occupy around 4 times of the space of as that of a car. So we cannot say for traffic density a bus and a car is equal. If there is n number of vehicle on a road, I cannot say the n number of vehicle are occupying same space if I am not converting them into PCU values. That's why I have to convert one type of vehicle into another type of vehicle in order to one type of vehicle into PCU value in order to uh, have a particular same relation or study condition. So there are different PCU values which you should remember for different type of vehicle classes. Passenger car as we are converting the values into PCU, passenger car unit, so passenger car is equivalent to a passenger car, so the equivalency factor will be equal to 1. A tempo or a auto rickshaw is also considered equivalent to a passenger car, although the speed may be less, but their condition, in prevailing condition, the speed is equivalent. The agriculture tractor, this is without the trailer. If we say agriculture tractor, the size of agriculture tractor is almost equivalent to a passenger car without a trailer, and speed is also good. So we will say for these type of vehicle, the equivalency factor will be equals to 1. Buses, as the size is enormous, trucks comparatively very large as compared to passenger car, and agriculture tractor with trailer units, the equivalency factor will be 3. Means if I have one bus, I'll say I have 3 PCUs, I have 3 passenger car units. Then motorcycles, because of size, they are taken as 0.5. Scooters and pedal cycles, they are taken as 0.5. Pedal cycles, yes, speed is less, but the spacing or the dimension which it covers on the road is very small as compared to car. So its speed will increase its equivalency factor, but the dimension will decrease its equivalency factor. Then cycle rickshaw, as we know, the cycle rickshaw are almost acquire particular space on a road, but the speed is comparatively less, so we will say equivalency factor is more than 1. Horse drawn vehicle, these are non-motorized vehicle. Almost all the non-motorized vehicle except this pedal cycle have the value of equivalency factor more than 1. So you can say that horse-drawn vehicle comparatively faster as compared to the bullock carts, so this value is 0.4. A small bullock cart and a large bullock cart, compared to the dimensions, the equivalency factor changes. So these values you should remember. In any question you may be asked to find out traffic volume, this is a very easy process, but in terms of PCU, whenever you don't remember the PCU, your easy questions will become tough for you. So better remember these few values so that you can solve this question with ease. These values are very important. Then this horse drawn vehicle, this is important, so you can remember. If you cannot remember all the values, at least remember these 4 values. Let's now see in terms of PCU what road volume, this is vehicle per day or PCU per day. So what density on road, or in terms of, sorry, what capacity in terms of flow, what capacity of road is there for a different lane condition or shoulder condition. It is assumed that a single lane road has a width of 3.75 meter with earthen shoulders. The shoulders are not paved, they are earthen shoulders. So these shoulders have a traffic capacity of around 1000 PCUs per day. If the shoulders are paved, or we say hard shoulders, then the capacity will be around 2500 PCUs per day. For intermediate lane, we know that the width of intermediate lane is 5.5 meters, but these are also with earthen shoulders. The PCU value will be 5000 per day. These values are, if it is divided, values are sum of both directions. For a two lane road, that is 7 meters with earthen shoulders, the value is 10,000 PCU per day. And a 4-lane road which is divided with a shoulder, divided with a median, then the value is 20,000 to 30,000 depending on the shoulder condition. So these are the values. No need to remember these values, as this is just for your information. These values are not being asked directly in any examination, or in GATE examination. These kind of questions in which you are asked about data, comparatively they are less. in GATE examination there are more questions from conceptual side. So better we'll move on to concepts like how to convert or what kind of vehicle is converted into PSU with what equivalency factor. So and so this is about PSU, passenger car units. Now let's start with another story. This is speed study, not story, it is study. Speed study, we know there are different type of speeds which we have already seen. We have seen spot speed, speed on a particular spot, or we can say speed which is instantaneous. Then we had studied running speed, journey speed, time mean speed, space mean speed. These were the speeds. This was exact speed or a spot speed. These are the average value of speed. This is all. These are the also average value, but for a particular stream. These averages are for different vehicles. The TMS and SMS values are for different vehicles. We have already seen how these values are, the TMS and SMS values are calculated, but we have not seen how the spot speed is calculated. So let us discuss some of the method to calculate the spot speed. Spot speed is measured using different instruments. Like you can use Doppler's radar, also known as speed gun. Doppler radar is an instrument in which waves are thrown at a object, then it is received back. The time difference will tell you about the speed. These are specifically used in order to calculate the speed of running vehicles on road. The Doppler radars are used by traffic policemen in order to find out the speeding vehicles. So speed guns or Doppler radars depends on or works on Doppler movement. Then we can use anoscope or mirror box. This is an instrument which helps us or which can allow us to see vehicle from a right angle. If we are here, we are standing here, and here is the mirror box. This is the section. The vehicle enter through this section. As it is here, I start my stopwatch, and as this vehicle reaches here, I'll be able to see the image of this vehicle in this box. So I will stop my stopwatch. I have this x distance, I have the time t, I can calculate the speed. So this is for a specific section. Then we can use pneumatic tube or pressurized tubes. We have already seen how pneumatic tubes or pressurized tubes can be used to calculate the speed. We can use loop detectors. So, or we can use our photographic images or video images in order to find out the speed, because these days we are able to develop various algorithms and various programs which can help us using artificial intelligence or data collection, at what speed, what kind of vehicle, what direction they are moving in. So these instrument can be used in order to calculate the spot speed. Now we are going to study about spot speed studies. The speed studies are actually divided into two types. One is study which is done in order to calculate the flow, and the study which is done in order to calculate the delays or densities. So there are two studies which we are going to study now. One is spot speed study and another one is your speed and delay study. Now we are starting with spot speed study. Spot speed is a speed which is calculated at an instance. So if we are calculating the value of speed at an instance, we will not be able to derive the value of density from this, because density is given with the space mean speed, or with value of this speed at a section, because density is the study of vehicle flow in a section, or the number of vehicle in a section. So spot speed study will not work there because it is for a particular spot. So spot speed study will be helpful in order to design the roads. It will help us in order to impose the speeds, because uh, if I tell you, whenever you are moving on a road or any highway, you must have seen some traffic limits. You should not go above 60, you should not go above 80, you should not go above 100. These were the limits which were being imposed for a particular section on road. When traffic policeman stops you for overspeeding, he is also using this spot speed measurement instrument, that is speed gun or Doppler's radar. So don't you think that that imposed speed is actually the spot speed or derived from the spot speed value? Yes, all the values which we see on road or the designing conditions, they are derived from spot speed studies. The values of spot speed studies are calculated and they are arranged in this kind of arrangement, where we have number of vehicles for a particular window of vehicle, window of speed, and then we calculate frequency and find out cumulative frequency. These cumulative values or frequency help us to find out different values of speed which we can use in designing a highway or imposing the speeds on the highway. So let us study the spot speed study through this table, and then we'll go back and understand why these values are important, how these values are studied, and we'll see how these values are calculated, and then we'll find out why these are important. So I have a vehicle which is running with 7 kilometers per hour. This will lie in the speed range of 0 to 10. So I have such 7 vehicles which are running with a speed between 0 to 10. Then there are different windows of speed and different frequencies of the vehicle. Some vehicles are running with a speed of 20 to 30 kilometers, 23, 24, 25. Some vehicles are running with speed of 50 to 60 kilometers. So such that we have calculated or we have counted the values. There may be different windows for this table, but we just want to understand how the values or how these values are used to calculate the frequencies or the design speeds. So we have taken uh, symbolic data. So here the values are written. Mid speed, in order to plot we need a particular value, because we cannot plot with the range. So this is 0 to 10, the mid speed is 5, then 15, then 25, then 35, 45, 50 to 60 is 55, and 65. You can see if I plot the number of vehicle here, this is the frequency. Let us count the total number of vehicle. This is simplest we use for, let me use calculator for the total number of vehicle are 159. If I plot frequency number of vehicle and this is speed, is, let us say 5, 15, and so on to 65. These are the speed values. These are 5, you can take 10, 15, 20. So if we plot the values with respect to speed, we will get a dumbbell shaped, or this is the normal distribution kind of curve. See the mid value, that is this 35. This is having the highest number of vehicles. So highest number of vehicles are moving for a particular window itself. So this distribution is known as normal distribution. This is the frequency curve of vehicle for speed. Now let us find out the percentage of frequency. Means if these values are raw values taken from the site itself, but if I want to convert these values in percentage in order to visualize it better, so I should calculate the percentage frequency. This is calculated by 7 multiplied by 100, in which I want to convert it, divided by 115. So this value will be 4.4. This is 10.06. 14.47. 30.19. 20.13. 13.84. 6.9, and the summation will be equal to 100. This is the percentage of vehicle which are running in these speed windows. We can easily see that this value is highest. We are starting with low, then we are increasing with values, we are getting on to the highest value, and then we are reducing. 30.9% of the vehicle are running with a speed of 35, or in a window of 30 to 40. This we can visualize. We can use this percentage graph to calculate. We can make same graph using the frequency percentage with speed. We'll get the same graph, but the y-axis value will be in percentage. We can find out the model speed value, the midpoint of this curve. This will be model speed. This tells us about the speed which is used by, or the maximum number of vehicles are running with this speed. So this is the model speed or model average. So maximum number of vehicles are comfortable at this level of speed. So this is the maximum number, and this is the speed value. So this is the modal speed. You can be asked in questions to calculate the modal speed from a given data. You can easily calculate the modal speeds, because here, to find out model speed, we should convert this value in cumulative frequency. How to convert this values in cumulative frequency? What is cumulative frequency? Cumulative frequency says that how many number of vehicles are running below this value. So we can say 4.4. So 4.4 vehicle are 4.4% vehicle are running with the speed of 5 kilometers per hour. This is also in kmph. 4.4% of vehicle are running with the speed of 5 kilometers per hour. Then 4.4 plus 10.06 06. These many vehicles are running with a speed less than 50 kilometers per hour. Then plus 14.47. These many vehicles are running with a speed less than 25 kilometers per hour. Plus 59. I'm just adding up these values. I'm adding up these values while I'm doing. Then 3.13, 79. This is 93.09. Add 100. As we have rounded off the values. So this is the cumulative frequency curve. Almost all the vehicles are running below this speed. 100% vehicles are running below this speed. So this is the frequency curve or frequency values in cumulative term. We should convert this cumulative frequency values in a curve where this x-axis is speed, this y-axis is cumulative frequency percentage. This curve, which will be shown to you, will be in this shape. This value is, the last values will be 100% and so on. The values will be decreasing here. So 100% vehicle will be running with the highest speed given in the window. Now there are some speeds which are used for various reasons. First one is 98th percentile speed. Where will be 98th percentile speed? It will be just here. What does this what the significance of 98th percentile speed? It says that only 2% vehicles are running above this speed. So in order to design a facility or a road, we should consider this speed. So this is actually the design speed. This is actually the design speed, the speed with which or considering which we design various geometrical features or features on road. So 98th percentile speed is the design speed. So we are not considering only the outliers. What are outliers? The vehicle which are running with very high speed. A very interesting thing. We'll talk about 85th percentile speed. 85th percentile speed. This 85th percentile speed is actually the imposed speed or safe speed limit. This is also known as imposed speed, safe speed limit. Whenever we are moving on road, we see a lot of symbols saying that the speed should be below this. 80 km per hour is the speed limit, or 90 km per hour is the speed limit, or 100 km per hour is the speed limit. Have you ever seen any highway with a speed limit of more than 120 kilometers per hour? Have you ever seen? If you have ever seen, please write in the comment box which highway has the speed limit of more than 120 kilometers per hour. I agree with at some stretches of Yamuna Expressway there may be speed limits of 120 kilometers per hour. I don't exactly remember or that I have seen it anywhere. But for safety concern, I can say it may be for the speedest highways, it may be the speed limit may be 120 kilometers per hour. But have you ever seen any highway with a speed limit of 120 kilometers per hour and above? No. Have you ever seen the speedometer on your cars? None of your speedometer is limited to 120 kilometer per hour. Even a car with 800 cc or with 1100 cc, the speed limit is 160, 180 in your speedometers. Why so? When roads are not allowing us to move above 120 kilometers, why the speeds are there? Because we have 15% of the vehicle which are moving above those imposed speeds. Vehicles are made to make you die. The speed limits are the safer limits in which you should drive in order to move safely. If it is the imposed speed is 80, if condition is good, you will definitely drive above 100. And this is the foolishness. And this is known by the designer. The designer know about this foolishness. That's why it designs for a speed limit of 98th percentile speed, but imposes a value of 85th percentile, which is safe limit. You know, there are some foolish people who will drive. There are 15% of the people who will drive above those imposed speed. So he will try to save maximum of those who are driving above, but he cannot save everyone because this will increase the cost of the design. And if we provide you a design, a better design, you will start driving at a better or higher speed. So there is no meaning of providing better facility, because better the facility is, higher will be the speed. So you cannot save everyone, you cannot limit everyone to a speed. That's why he tried to design the roadway in a speed limit of 98 percentile. Only 2% vehicle are left, or are those who will run above this design speed. But he will save 13% of the people above, or the drivers above 85th percentile speed. So you should remember that design speed is 98th percentile speed from this frequency chart, and the imposed speed is 85th percentile speed. This is the higher limit of the safe speed limit. Then another one is the lower limit or lower safe speed limit, that is 15th percentile speed. So this speed is the lower limit, because if we are moving below this speed, we will create a condition of congestion, or there may be accidents with the higher speed vehicles. So that's why you should not drive below 15th percentile speed, and this speed is around 10 to 20 kilometers per hour. It is hardly possible to drive at this speed if you are moving. If you are talking on phone, better you should park your vehicle in the service lane and then talk to someone, talk on the phone. While driving, if you are driving with slower speed, you are a threat to the coming vehicles. So this is the lower speed limit. Here this is 15th percentile speed. One, the 50th percentile speed is the model speed, with which the maximum vehicles are moving. It is not exactly the middle speed, but you can calculate the value using the curve, which we have already seen. So these are the various speed which you should remember in order to find out the design speed or safe speed limits. These can be calculated from this given data. If we want to find out 85th percentile speed, or someone says from this data calculate the imposed speed, so you can calculate the imposed speed by interpolating between these two values. 85th percentile will be somewhere here, so you can use these two values and interpolate. So 85th percentile speed will be equals to something 45 plus some value. There will be some ratio or the slope of the curve. What will be the ratio? 55 minus 45. What is the percentage of vehicle moving at a speed of 55? 93.09. This is 93.09. What is the percentage of vehicle moving with a speed of 45 kilometers per hour? 79.25. So this is 79.25. If this is a percentile, we want only speed, we have to multiply this value with a percentile, that is 85. So let us calculate this value. Error which I am making, I think. Okay, sorry, this is not 85. There's multiplication of 85 minus 79.25. How much it is above? This is 49.15 kmph. This is how you can calculate 85th percentile speed. Similarly, you can calculate 98th percentile speed. So you can say 98th percentile speed will lie between this and this value. So I will take 65 and 55 as 55 plus some value. My 98th percentile speed will be more than 55, but how much more than this we will see. 65 minus 55 divided by, this is your 100 minus 93.09. I want the speed of 98. This is 93.09. Let us calculate the value. The value is 62. So what does this mean? I will design for the speed, that is 62.10, but I will impose this speed value in order to keep you safe. But if you are moving between this value, I have already designed a cushion for you. I have designed the facilities to keep you safe. But policemen will not keep you safe. They will charge you if you move any speed above 49.15 kilometer per hour. So this is how the speeds are decided. This is how the speeds are imposed. These depend on your spot speed. Till now in spot speed, we were not able to find out the density characteristic. because flow characteristics can be calculated using the spot speed but not density characteristic. In order to calculate the density characteristics, we should go to another study, that is a speed and delay study. Speed and delay study can be done on a road stretch in order to find out the delays and various sections where delays are more. There are various methods which can be used to calculate the speed and delay study. One is floating car method. We are going to study this method extensively. Then license plate method or vehicle number method. There are control points for a section, roads coming out here, roads coming out here, roads coming out here, road coming out here. On all those control points, we will have our surveyors. They will note the number of vehicle moving or the license plate number of the vehicle moving out or moving in from this section. They will collect the data. The data collection is not very tough, just you need to write the number of vehicle or the registration number of the vehicle. Then we will take the data into the laboratory or our workplace in office. We will have to compute the vehicle entering the section from a particular road, coming out of that section from particular road. We have to match the numbers, or we have to make relative analysis of those numbers which are moving on the road. So this method is easier in data collection but bit complicated in computation. This can be used in order to find out the speed and delay studies. Then the interview technique, it is a very easy technique but difficult in order to make people speak. If they are cooperative, this is the easiest method. You have a questionnaire with you, you select a sample size of 5 to 10%, and then you can ask question by interviewing them. They replies, if the replies are genuine, you have a very good data collection from a good sample size. You can use that sample size in order to find out the delay reasons. Then photographic techniques, you can use video cameras, video capturing, video analysis in order to find out the delays on a particular route. Let us start studying the floating car method. It is a very you should say kind of authentic method which will tell you about the spots where delays are occurring, why the delays are occurring, what duration of delays are there. So this method is required a lot of people to work with. There is a test car which we run along a route with number of people. Let us say we have 4 observers sitting in the car. They are observing various values. This car is made to move various trips in the study route. Let us say the route is north-south and it is also studies in south-north, means the direction is north-south to south-north. Here is observer 1. Observer 1, you are moving on this route. Let us say this is the route. There will be traffic moving in this direction, there will be traffic moving in this direction, there will be points where there will be delays, there will be intersections. So observer 1 क्या करता है ये? It notes the time at various control points, bridges, intersections and other fixed points. Actually delays are, जो आपके delays होते हैं, there are fixed delays when there will be delay, and this is fixed like your traffic light. And some delays are actually not fixed. Some delays are conditional delays. There may be a condition of bottleneck, there is some construction going on, there is some accident. So these are conditional delays. So fixed delays cannot be removed. They are part of your route. But conditional delays, they can be prevented. Or if there are fixed delays which are making the trip very tedious or reducing the level of service, you can reduce the fixed delays also. So observer 1 will calculate the total delay time plus the point or the section of delay. कहाँ देरी हुई और किस वजह से हुई, or you can say cause of delay. Observer 2 is sitting with the stopwatch. He has started the stopwatch while starting the trip. Now, at what time of the trip the delay occurred? So he will see the time of the duration, calculate time duration the trip during the trip when this delay is occurring, the location and the cause of delay. Here I have also written the cause of delay. It is the type of delay that is intersection or fixed, say fixed cause. This is the cause of delay which is conditional. Then observer 3 will note the vehicle which are overtaking the test vehicle and the vehicles which are overtaken by test vehicle. Observer 4 will count the number of vehicles from opposite direction. Opposite direction में जो vehicle आ रहे हैं वो count करेगा observer 4. So we can write the values which we can use in order to find out the total time or total journey time, that is t bar. This is your total journey time in one direction. Let us say we will talk about when we are moving in north to south direction. So what is the total journey time for the north to south direction? Then we have this value x. This is vehicle from opposite direction. You can write it as x1 vehicle from north south when test vehicle moving in south north direction, and this is x2 vehicles from south north when test vehicle is moving in north south direction. So this is x1 and x2. So vehicle are in opposite direction. I have defined x1 and x2 in order to find out or put this value in the question for less confusion, in the not in question, in the equation for less confusion. Y value, number of vehicle, or you can write directly as overtaking vehicle minus overtaken vehicle. The number of overtaking vehicles which are overtaking the test vehicle minus number of the vehicles which test vehicle has overtaken. Then TW, journey time in north south direction. We are calculated in north south. TA, this is your journey time in south north direction. Whenever you are returning back, you have to do the same things, you have to calculate the same values. So T bar will be equals to, whenever I am moving in north south direction, I should take the value of TW because I am moving in north south direction, minus Y into TW minus TW plus TA divided by X1 plus Y. This is the formula. This formula is used to calculate the values of average journey time in directions in which we are moving. Like for north-south vehicle or north-south direction, when our vehicle is moving, we can use the value of X1, the vehicle which are coming in north-south direction when we are moving in south-north direction. So all the values here which we have used are except the TA value, that is south north direction, all the values are not from count of the vehicle or count of the time from north south direction. This is overtaking vehicle and overtaken vehicle when we are moving in north south direction. So this is all for north south direction. If we are moving in south north direction and we need to calculate the time, we should use the values of south north in place of north south. In that condition, the X2 value will be used, the number of vehicle from south north when we are moving in north south direction. So this is not important where we are moving, where the vehicles are moving. This is relevant to the average time of the route. This is how we can calculate the value. From this T value we can calculate mean velocity. This is total length of the stretch and divide by T bar. This is your mean velocity on that route. You can calculate the traffic volume using the formula X plus Y divided by TW plus TA. This X will be as per the direction. If we are moving in north south direction, it will be X2. If we are moving in south north direction, it will be X1. So this is how you can calculate all the values, and I don't think there will be questions based on the formula in your GATE examination. The questions will be based on the floating car method and how it is done, or what kind of method this is. This is a speed and delay study method. So this is the floating car method, which is used to calculate the delay on the roads or the locations of delay on the roads. This is all about the spot study. Let us see one question. This type of question you can see in your examination. This is a conceptual question. So this question says, match the list 1 with list 2. List 1 is your speed, different type of speed which we have already studied, that is space mean speed, journey speed, running speed and spot speed. And these are the applications of this speed. Let us go to the application and then study. Tell me about the road condition study. What kind of road it is? How do we see a road when we are measuring the spot speed? Can we measure the spot speed and say what road condition is that? No, because spot speed is about a spot, about a section. We cannot tell you about, or we cannot confirm about the road condition with just the spot speed. Journey speed will include the delays, which is the stop time, the delays. So if the delay is because of intersection, we cannot say what road condition is this. So we want running speed, means the speed on the road itself when we are moving. That if it is less, the road condition is not good. If running speed is good, the road condition is good. So road condition is related with, or this running speed can be used or can have an application in order to calculate the road condition or see the road condition. Then we have regulatory measures. Regulatory measures, let's come on the regulatory measures later, because journey speed also can have tell us about regulatory measures, and spot speed also can tell us about regulatory measures which we need on the road. Traffic flow studies. We know that traffic flow can be calculated by Q is equals to density into your velocity. Your density is 1 by space headway, and your velocity is actually space mean speed. So flow will be calculated using space mean speed. Okay, we have one more match here. Space mean speed will be used to calculate traffic flow studies. Then we have delay studies. When we were talking about running speed, we said there is no delay which is counted in running speed, but it is counted in journey speed. We have two options left. One is journey speed, another one is spot speed. The spot speed will not tell you about the delay. The delay will be accounted in your journey speed. So journey speed can be matched with your delay studies, and what left, that is spot speed, which we have already seen that spot speed is used to mark your 98th percentile speed, that is design speed, 85th percentile speed, which is your safe limit. So we use spot speed to regulate your traffic flow or the traffic speed condition. So this is all for today. In next class, we'll talk about further studies like OND studies, origin destination studies, parking studies, and accidental studies. Thank you so much.